Now we're going to take a look at some of the slopes on the translation that we were looking at before, the slopes of BC and B prime C prime. Well, the slope from B to C, which is right here, that's negative 2 over 4. And the slope from B prime to C prime, we go down 2 over 4, that's also negative 2 over 4. That means these two segments are parallel since their slopes are the same. AC and AC prime are also parallel because their slopes are 0. That is, they're completely horizontal. And then AB and A prime B prime are parallel since both of their slopes are undefined. That means they're going straight up and down. Now let's take a look at the angles. Can we tell if they're congruent or not? Well, angle A is congruent to angle A prime for sure because this segment AB is perpendicular to AC. And A prime B prime is perpendicular to A prime C prime. Well, that means those are right angles, and all right angles are congruent. Angle B is congruent to angle B prime because, well, let's draw a transversal. So I kind of put these triangles this way on purpose so I can line them up. And then I'm going to draw the two parallel lines going vertically. Highlighting the angles, you should see that those are corresponding angles. Well, if the verticals are parallel, which they are, then the corresponding angles are parallel. So, congruent. So these are corresponding angles on the transversal that intersects the parallel lines. So B is congruent to B. Angle B is congruent to angle B prime. Looking at angle C, I can do the same thing. Draw the transversal, and then show the parallel horizontal lines, highlighting the angles there. Those are also corresponding angles on the transversal, so they are also congruent. Now, since the segments are parallel, their direction remains the same. So translation is a rigid motion in which every point is moved the same distance, which you saw in the previous page notes, and also in the same direction. Now we're going to look at translations as functions. How do we write them in coordinate notation? Well, for my pre-image here, I can write down the coordinates for A, which are negative 4 and negative 2. A prime is 2, negative 5. For B, it's negative 4, 0. For B prime, it's 2, negative 3. For C, it's going to be 0, negative 2. And for C prime, it's 6, negative 5. Well, if you look at it, how's it behaving? It's going to the right 6 and down 3. So I can actually say in notation, it moves, first of all, in words, it moves right 6 and down 3. In function form, it's x, y goes to x plus 6, because that's to the right, and y minus 3, because I'm going down. So if I go to the right, then it's plus the number. If I'm going to the left, it's minus. If I'm going up, it's plus for the y. And if I'm going down, it's minus for the y. Now we can always write this as an expression. And the way you do it is you do this t for translation. Then you say the 2 points, the original point on the pre-image and the final point on the image. So in this case, I could say A to A prime. Or I could say B to B prime or C to C prime. So in this example, we're going to write the translation as a function and as an expression. You can see that A moves over 1, 2, 3, 4, 5 units. And so does B, and so does C. So I can say x, y goes to x plus 5, y. There was no change vertically, and that's why the y did not change. I can also say that it's the capital T with the original point and the final point. A prime, B prime, or C prime. Any of those would work. So for further reflection, how do the distances from the points on the pre-image to the points on the image compare? Hopefully you saw for a translation, all the points move the same distance. Another question to consider is, what is a translation? What does that mean? What defines a translation? And what are the different ways of writing a translation?